Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code OEC 754, Unit 3, topic Dialysis. Objective to understand about the concepts of dialysis and the different types of dialyser. A dialyser is an artificial kidney designed to provide controllable transfer and reduce the accumulation of waste products from blood. Functions of natural kidney is form urine out of blood plasma and maintaining acid-base balance. Here two important processes of kidney is removal of waste products from blood, regulation of the composition of blood. First, we are going to see the artificial kidney. It is used to reduce and removing impurities from blood. Suppose in case of severe renal failure problem, kidney transplantation is a permanent solution but temporary treatment is dialysis. For example, in case of renal damage, the plasma creatinine level in the urine is reduced below 7 to 40 millimole per day. The advanced renal failure is due to inflammation of the kidney, abstraction of urine by stones or tumors. Acute and chronic renal failure are treated successfully by dialysis. Home kidney dialysis. There are two basic classes of dialysis machine. First one is clinical unit. And the next one is home use dialysis machine. Here the patient with complete renal failure would need to visit clinic at least 3 times per week. Then the patient with the beginning stage home use machine are more flexibility and more frequently used in home for longer period. It also easy to cleaning and disinfecting. The device has flow rate of blood up to 600 ml per minute, and also it includes batteries because it provides uninterruptible power supply. Next one is dialyzer. It is an important part in the artificial kidney systems. The treatment actually takes place in remove waste products from blood. It consists of two circuits, one in which with blood circulates and the other one is which dialysis fluid follow. Here it consists of three types: coil dialyser, parallel plate dialyser, hollow fiber dialyser. First we are going to see the coil dialyser. It is an early design in which the blood compartment consists of one or two long membrane tubes placed between support screens and then tightly wound around a plastic core. That means the coil design did not produce uniform dialytic flow distribution across the membrane. It will be most efficient device has replaced the coil design. Next one is parallel plate dialyser. It is the most commonly used dialyser is a parallel flow dialyser. It is also called as a kill dialyser. Here it consists of three polypropylene dialysing membrane. That means a sheet of membrane are mounted on plastic support screens and then it arranged in multiple layers ranging from 2 to 20. This type of dialyser allows parallel blood flow in multiple and dialysis flow channels with low resistance to flow. There are some major improvements while using this type of dialysis. They are thinner blood and dialysis channels with uniform dimensions, minimize masking or blocking of membranes on the support, minimizing stretching. Next one is hollow fiber dialyser. This is the most effective designed for providing low volume, high efficiency devices with low resistance to flow. It is the fiber in the device are termed as fiber bundle. Here also the fibers are plotted in polyurethane at each end of the bundle in the top sheet, which serves as the membrane. It is also used for the reduction in infection risk and also reduced in the cooperator setup time. Then the dialysis, it is the process by which the waste products in the blood are removed and restoration of normal pH value of the blood obtained by an artificial kidney machine. So it is also called as a diffusion. Here also the process of water removal from the bloodstream is called as ultrafiltration, and the amount of fluid removal is called as ultrafiltrate. It is also known as convection. Here also two types of dialysis method is there are hemodialysis and peritoneal cavity dialysis. First one we are going to see the hemodialysis. It is used for the production of warm dialysate which is then circulated through an external dialyser assembly. In this block diagram, it also controls the cycling of the blood from the patient through artificial kidney and back to the patient. Here, the proportioning pumps is used for the olden days mixing large amounts of dialysate from dry chemicals in time consuming and laboratories. Incoming water can drive proportioning pumps and it eliminates the need of a motor, and the proportioning system may be of two types, that means fixed ratio or variable ratio type. Suppose if you are using fixed ratio type means it is the ratio of concentrate and water is determined by the ratio of two pump piston diameters. These are mechanically fixed and ratio of 34:1. Suppose if you are using variable ratio type, variation means it is a plus or minus 5% on the standard dilution ratio, that is 34:1 is possible. And then the flow meter. It is measured using a flow through transducer which produces a precious number of pulses per minute. And the next one is conductivity measurement. It is produced in the continuously monitored by conducting cells to verify the accuracy of proportioning. And then next one is venous pressure measurement. It is normally measured at the bubble trap. That means the sensor connection should be maintained in the same location during dialysis. The next one is effluent pump. It is used to maintain the flow of blood while dialyzed. There are several designs available, for example gear type, otherwise magnetically coupled. The next one is heating pump. It is usually a plastic syringe type having a capacity of 30 cc used to deliver heparin from the pump is calibrated in centimeter per hour. The next one is intracorporeal dialysis. It acts as a natural filter to remove waste product from blood. Dialysis fluid 1.5 to 2 liter enters the peritoneal cavity through a tube called catheter surgical inserted into abdomen. Temperature control circuit is used to maintain the temperature of dialysis fluid at 37 degrees Celsius using thermistor. Thank you.